So let's suppose that we had a set of bivariate data and we actually had a population distribution to sample from. One of the things we might want to do is use a confidence interval to estimate the population slope. And so what we might want to do is take a sample, measure the sample slope, and then use a t-distribution to create our confidence interval. So I'm going to show basically the conditions you need to check and the plots you're going to have to look at in order to make those conditions sure those conditions are checked. So let's say that you wanted to take a sample of a population. So I've got a population data here. I can take a look at it. It looks like I've got 99 students, their GPA, and maybe we're using that to predict their ACT. Now I'm going to take a look at what does that look like graphically. It looks like this population scatter plot. But typically we don't have the population. Typically what we're doing is we're taking our population and we're sampling from it. So I'm going to sample cases. And I'm going to do, let's say we're going to do a sample of 9. Replace existing cases, sure. And not with replacement. We don't want to take the same student twice. Before I do this, let's look at what came in just to make sure I did it correctly. By default, it did 10, and we can take a look at those graphically. GPA, predicting ACT. Now I'm going to go ahead and sample more. There's 9 more. I might be interested in the least squares regression line. I might be interested in, actually, before I get ahead of myself, let's talk about the conditions that we need before we run our confidence interval. So in order to do the confidence interval, we're going to have to check some conditions. And those conditions make up the acronym LINER, which stands for linear, independent, normal, equal variances, and random. Some of these, we're going to need to use plots as our evidence. So for linear, one of the things we do to say that this least squares regression line was actually linear is we look at a residual plot. So in Fathom, we can right-click, make residual plot. And in this residual plot, we're looking for the residuals between the least squares regression line and each data point to be essentially random. And I look across and I look for patterns and I say, I don't think I see any patterns here. So that leads me to believe that the least squares regression line was approximately linear. The next condition we need to check is for the independent condition, we would just comment that we believe students are independent and that their scores are independent. We might also want to check the 10% condition and say that we expect that there were more than 90 students in the population, and there were, because we can see there were 99. For the normal condition, we're actually looking to see, are the residuals normally distributed? So what I need to do is I need to create a list of residuals, and I need to show my equations, show formulas, and let's add a formula. And this is under statistical and bivariate. We can see ln reg residual, and it says that I need to say predictor response. So I'm going to go back up, just click on my attributes. I want to use GPA, comma, ACT. There's a list of residuals. And in order to see if they're normally distributed, I might want to look at them graphically to say, are there any outliers? I don't think so. Any strong skewness? No. So we can say that we can assume that that's approximately normal. And I notice there's a problem. I have 19 instead of 9. So what happened was I have the first 10, and I needed to replace them. So let's go ahead and sample again. So we're going to sample. And let's replace existing cases, and let's do 9 of these with replacement. And everything should update as we do this. So it did a new sample. Let's see. It's not exactly what I want to do. I want to sample again from here. Let's replace 9 more, and that way everything updates the way I want it to. So I have a sample size of 9. I can see the residual plot. I can see the sample slope was 8.07. I can look at the residuals and say, I don't see a pattern. They look pretty random. And then we can look at the graph of the residuals and say, no outliers, no strong skewness. We can assume that these should be approximately normally distributed about this least squares regression line. Another thing to look at might be normal probability plot, which Fathom calls normal quantile plot. And we can see, is this approximately linear? Yeah, no big patterns going on here. So this also leads us to believe that normality condition of residuals, which is why it's called normal quantile plot, is met. So I go back to my list and I say, yep, normal condition is met because the residuals are approximately normally distributed. Equal variances. In this case, we look for the residuals. So we're looking at these residuals, and one of the things I want to look at here is just the residual plot. And I want to say, does it seem like they're in about the same range from the residual line of residuals equals 0? Meaning, do they seem to be getting further away from the regression line, or closer to the regression line, or do they seem to be in the same range? And I would say, yeah, the variance seems to be staying the same. I can see one high here, one low here. There's another one about that far away. It doesn't really seem to be over as GPA gets larger. It doesn't seem like the variance is getting higher. And as GPA gets smaller, it doesn't seem like the variance is getting higher or lower. And so we would say that that condition, equal variances, is also met. The random condition we would just quote from the text, and we would say that we randomly selected 9 students using Fathom. And that is